After that we have chimneys, dams and retaining walls. I don't understand why they have included this part chimney here and dams and retaining walls here. Okay, this is nowhere related to this moment of inertia, stress and all. Okay, something it is missed here. Then after that eccentric loads is there. This will come in a compound this one bending stress and shear stress. Therefore today we will be discussing this much. Okay, this red underline we will be discussing moment of area. Moment of area is nothing but cg and moment of inertia mi. For rectangle and circular section they have mentioned rectangle and circular section, but you study other sections like circular is already mentioned. You study square section, rectangular section and triangular section also. Even we have to study some diamond and T sections and all. Those also we have to study moment of inertia for them, compound sections. Hmm. Because sometimes they will ask. Okay, little bit we will understand those things. Bending stress is there. We have to study shear stress. For T section and channel section they have mentioned. Default we will be having circular and rectangular, triangular. They will be there. Okay, don't go word by word in the syllabus. You study more than the syllabus. So that little bit more. Okay. Then after that, this chimney, dams and retaining walls we'll study in some other chapters. Eccentric loads will come in the bending stress and shear stress. Okay. This much we will be concentrating today. Right. Now we will go ahead. Okay. Moment of inertia and centroid. Okay. First, we have to understand what is centroid, and after that we will come to moment of inertia. Okay. Let us consider, before understanding centroid, we will understand center of gravity. Center of gravity. Okay. Everyone will be having a notebook now. You have your own notebook. Okay, now this is your notebook. Notebook is in three-dimensional object. Correct? This is your notebook. Many times we have made one that event that you will be having your fingers like this, you know, then after that you will put your notebook. Right? Then you will be rotating that one. Now see, this notebook is just sitting on a tip of a finger. You know, that point where you are exactly you are holding that notebook is this point. Okay, why you are holding that one? Why not you are holding the entire this one? You know, this is your hand, entire notebook. Instead of holding entire notebook, okay, from here and there, you are just holding it one finger. Okay, one finger. Then you already know that the entire mass is concentrated on particular point. The mass is concentrated on particular mass. Why mass is concentrated on particular mass, particular point? Because notebook has its own mass. Notebook has its own mass, therefore that mass is concentrated at one point. Now let us consider the same notebook. Then the notebook thickness is something, some thickness is there here, some thickness is present. If I make that thickness equal to 0, what you will be getting? If thickness equal to 0 for the same notebook, thickness equal to 0, thickness is very less. If I consider, then you will get a paper. Okay, paper will also have some thickness, but even though that thickness you make it 0, then what is left? That whatever that is left is called as the area. Whatever that is left when thickness is made 0 is called as area. The same way, when the entire mass is concentrated at one point, like that entire area will concentrate at one particular point. That particular point is called as centroid. That point is called as centroid. Then if the mass is concentrated on a particular point, then that point is called as center of gravity. center of gravity. This difference you should know what is the meaning of centroid and what is the meaning of center of gravity. Center of gravity means against the gravity one point is there where every mass is concentrated. Centroid means it is just a thin lamina. We will call it the lamina. Lamina means where thickness is very ignorable or zero. Then the entire area is concentrated at point, that is called a centroid. Okay. Here, while explaining, I have considered a rectangular shape. Therefore, it is very easy to determine the center of the rectangle because common sense will tell us that the center will be here. Even though if I draw a circle, then common sense will tell that this is the circle, the center of the centroid of the circle will be at the center. Like that, few square also. If I draw one square, then where is the centroid? Then that will be center of the square. Like that, some regular shapes we know where that exactly that center will come. But when you think of this triangle, okay, some students who studied about this, they may mark this one. Triangles are many types. This is also triangle, this is also triangle. Okay, like that we have many types of triangles where exactly that center of gravity will come or centroid will come, that we have to study. Apart from that, we have semicircles and quarter circles like T section, C section, L section. Like that, many sections will come in engineering where we have to determine center of gravity, even I sections like that. Okay, and sometimes circular also, but hollow circular, square also, but hollow square, rectangle also, but hollow rectangle, right? A triangle also, but hollow triangle. Like that, we will be having many sections. We need to identify the center of gravity of those sections. That will be covered in this centroid chapter. Right? Conclusion. Till now, whatever I discussed, the conclusion is centroid is different, center of gravity is different. Center of gravity where mass will be concentrated, centroid where area will be concentrated. Right? Then we have some normal regular shapes. For them, common sense is enough to determine the centroid, and some shapes we have to study more about centroid or center of gravity. Right? This is that is the just difference between the center of gravity and centroid. You can read this one later. Okay. Now, what is moment of inertia? Moment of inertia. Wherever the word inertia will come, that inertia indicates the jerk. Okay, jerk antar. Jerk ಅಂತಂದ್ರೆ when you sit on this example, even since from childhood we know this example. When you sit on a bike, when you sit on a bike, then suddenly if the bike moves forward, then you will just go backward. There will be some jerk. That jerk is considered as a inertia. Then moment of inertia means about one particular axis, that jerk will happen. Okay, let us consider this is one plane. Okay, if I apply some force here and some force here, then this plane that plane will rotate like this. Sorry, ulta. Okay, let us consider this is a plane, and if I apply one moment here and one moment here, or some rotational force, then this will rotate like this, correct? This will rotate like this. Okay, this slided here and this slided here. About this center point, this is jerked. Jerked is my word, it's not English word. Just it is jerked, and that jerked is called as a inertia. That is moment of inertia. Okay, about what axis? This center axis, it is jerk. You know, that effect is called as moment of inertia. This we cannot show it by demo. That will be inside, the material will feel. That is called as moment of inertia. This is a practical application I explained. But theoretically, if I want to explain, then what is moment of inertia? Sorry, moment of area. That is your centroid. That is your centroid. Center of gravity. Both are somewhat same. Center of gravity. Okay, here thickness is there and here thickness is 0. That's it. Only these two differences are there. Okay, now these two mathematically we will tell it like centroid is equal to centroid will be getting by moment of area. Moment of area. Moment of area means about one particular point. For example, this is a rectangle. This is a rectangle. Then this is x-axis and this is y-axis. Then this area will rotate about this axis. This will rotate about this. If this is considered as a constant, then this will rotate about this axis. Let us draw it in the different way. See, this is your side view of the rectangle. Now this is at this point. This axis is here. This is axis, and this is a side view of that plane. Then this CG will be here. That CG will be here. If I apply some force here, what happens? This will rotate like this. Correct? But here we are not applying some force, but we have to consider the entire area is concentrated on that area may come like this. Okay, this may rotate. This effect is called as a moment of area. Moment means rotation. Moment of area, that is centroid, or moment of mass, that is your gravity. Center of gravity. Moment of mass is center of gravity, and moment of area is centroid. Right? Now we will be having another effect, that is moment of inertia. Moment of inertia. Moment of inertia is nothing but second moment of area. Second moment of area, or you can write it like moment of moment of moment of moment of area. Right? This is moment of area, or second moment of area is considered as a moment of inertia. Then how to get it? Look at here. If this is a y bar, then moment of area is nothing but area into perpendicular distance. Area into perpendicular distance. Right? Then moment of area, that is your mi, is nothing but area into perpendicular distance into perpendicular distance. Therefore, area into distance square is nothing but moment of inertia, and moment of area is just a into d. This is equation, and they are the statements. Right? Now again, conclusion. Conclusion is centroid, moment of area, center of gravity, moment of mass. Moment of area means area into perpendicular distance. Moment of mass means mass into perpendicular distance. Moment of inertia, it is a second moment of area, or moment of area means area into perpendicular distance into perpendicular distance, two times. That is your moment of inertia. Now we have centroid also and center of gravity also, right? Centroid, corresponding to that, we will be having moment of moment of moment of area. Then center of gravity, corresponding to that, we will be having moment of mass. Okay, therefore in general, in later, if I call moment of inertia, means defaultly it is moment of area, default. But if I want to express mass moment of inertia, that I will particularly call it as a mass moment of inertia. Mass moment of inertia means moment of mass. ತಿಳಿತಾ? ಮೊಮೆಂಟ್ ಆಫ್ ಇನರ್ಷಿಯಾ ಅಂದ್ರ ತಿಳ್ಕೊಂಡ್ಬಿಡ್ಬೇಕು ಏರಿಯಾ ಅದ ಅಂತೇಳಿ. ಮೊಮೆಂಟ್ ಆಫ್ ಮೊಮೆಂಟ್ ಆಫ್ ಇನರ್ಷಿಯಾ ಅಂತೇಳಿ ಮಾಸ್ ಅಂತ ರೆಪ್ರೆಸೆಂಟ್ ಮಾಡಿದ್ರೆ ಅಲ್ಲಿ ಮೊಮೆಂಟ್ ಆಫ್ ಮಾಸ್ ಇರ್ತದ ಅಂತ ತಿಳ್ಕೊಬೇಕು. ನಾ ಏನೂ ಹೇಳಿಲ್ಲಪ್ಪ, ಮಾಸು ಹೇಳಿಲ್ಲ, ಏರಿಯಾನು ಹೇಳಿಲ್ಲ, ಬರೀ ಮೊಮೆಂಟ್ ಆಫ್ ಇನರ್ಷಿಯಾ ಅಂತ ಹೇಳಿದ್ರೆ ಅದು ಮೊಮೆಂಟ್ ಆಫ್ ಏರಿಯಾ. ಮಾಸ್ ಅಂತ ವರ್ಡ್ ಯೂಸ್ ಮಾಡಿದ್ರ ಮಾಸ್. Some textbooks now in higher studies ಒಳಗೆ ಹೋದಾಗ ಮಾಸ್ ಜಾಗದೊಳಗೆ ವೇಟ್ ಅಂತ ಬರ್ತದೆ. ವೇಟ್ ಮೊಮೆಂಟ್ ಆಫ್ ಇನರ್ಷಿಯಾ ಅಂತೇಳಿ, ವೇಟ್ ಮೊಮೆಂಟ್ ಆಫ್ ಇನರ್ಷಿಯಾ, ಅದು ಮೊಮೆಂಟ್ ಆಫ್ ವೇಟ್ ಅಂತ ತಗೊಳ್ತಾರೆ. ಓಕೆ, ಇದು ಬ್ಯಾಡ್ ಇದೆ ನಮಗೆ. ಈವನ್ we will not concentrate on this also. Correct? We will concentrate on moment of inertia, that is your moment of area. Right? Now you can read these all points later, those are all covered. Now you can see here moment of inertia, they have written here mass into, see here mass is written now, mass moment of inertia means mass into perpendicular distance into perpendicular distance, that is mass into moments perpendicular distance square. Why this I is there and summation is there? Because if you have some many masses, this is m1, this is m2, this is m3, this is m4, like that, then you have a perpendicular distance r1, r2, r3, like that, then you can add all of them and you will get a moment of inertia. Okay, notice that the moment of inertia I depends on the distribution of masses in the system. The furthest the mass in the rotation from the rotation axis, bigger the moment of inertia. Then this, just you remember this one. For an object, the moment of inertia depends on where we choose the rotational axis, that is common sense. This is cs ಅಂದ್ರೆ common sense. The rotational dynamics ಅಂದ್ರೆ ಏನಂತಾರೆ ಅವರು, moment of inertia ಎಲ್ಲಿ ಬೇಕಲ್ಲ ಅಲ್ಲಿ ತಗೋರಿ ಅಂತ ಹೇಳ್ತಾರೆ ಅಷ್ಟೇ. The rotational dynamics moment of inertia I appears in the same way that the moment mass m does in linear dynamics. This is the comes in dynamics, not for statistics. Okay, next is bad mass moment of inertia. ಇದನ್ನ ಬೇಕಾದ್ರೆ ಸುಮ್ಮ ಎಕ್ಸಾಮ್ ಹಿಂದಿನ ದಿನ ಬಯಾಟ್ ಹಾಕೊಂಡು ಹೋಗ್ರಿ, memory power ಇತ್ತಂದ್ರ, otherwise you can skip it. Okay, now coming to mass moment of inertia, that is MOI or MI, or second moment of area. Second moment of area means moment of area, right? That they have written here. This is a dA is a small area and y is a perpendicular distance, another y is a perpendicular distance, therefore dA into y square. This is for a small area, and if you integrate this one, then you will get a big area. Okay, this is theory. Okay, we don't want these equations to be remembered, because this is just theory. You should remember. Later we will, this one we will consider, right? Now perpendicular parallel axis theorem for an area. Now look at here, this is very interesting. Why we want parallel axis theorem, that we should understand. See, default ಅಂದ್ರೆ ಗೊತ್ತಾ, ನಾವು ಏನು ಹೇಳಿಲ್ಲ ಅಂತಂದ್ರೆ, if anything is not particularly said, then every section will have its own moment of inertia about xx or cg, gg. Okay, every section will have its own moment of inertia about centroidal axis. ಪ್ರತಿಯೊಂದು ಸೆಕ್ಷನ್ಗೂ ಐ ಜಿ ಜಿ ಇರ್ತದ. ಎಲ್ಲಿರ್ತದ ಅಂದ್ರೆ ಸೆಂಟ್ರಾಯ್ಡಲ್ ಆಕ್ಸಿಸ್ ಒಳಗೆ ಇರ್ತದ. ಬಟ್ ಐ ಆಮ್ ನಾಟ್ ಇಂಟ್ರೆಸ್ಟೆಡ್ ಇನ್ ಸೆಂಟ್ರಾಯ್ಡಲ್ ಆಕ್ಸಿಸ್, ಬಟ್ ಐ ವಾಂಟ್ moment of inertia about this axis. Call it as a BB, base. Or I want moment of inertia about somewhere this axis. Or I want moment of inertia about this axis. Then what I have to do? Okay na? ಅಂದ್ರ ಐ ಜಿ ಜಿ ಇದು ಗೊತ್ತಿರ್ತದ, ಅದನ್ನ ನನಗೆ ಟ್ರಾನ್ಸ್ಫರ್ ಮಾಡ್ಬೇಕು. ದಿಸ್ ಮೊಮೆಂಟ್ ಆಫ್ ಇನರ್ಷಿಯಾ ಐ ಹ್ಯಾವ್ ಟು ಟ್ರಾನ್ಸ್ಫರ್ ಹಿಯರ್. This moment of inertia which is known, I have to transfer here, I have to transfer that here, like that I have to transfer. To transfer that one we have parallel axis theorem. To transfer moment of inertia we have parallel axis theorem. Okay, what is the meaning of transfer, or which equation I have to use? Okay, let us consider this IBB. IBB is the moment of inertia required in the base. Then that is equal to IgG plus area into h square is the equation. What is this h means? Where you want to transfer that height is called as h. This is your h. If you want to transfer to BB, then this is your h. If you want to transfer that one to the last axis, then this is your h. H is the distance between the central axis to where I want to transfer. Okay, na? That is your H. Area is the complete area, and IgG we will be knowing this one. This theorem is called as parallel axis theorem because you are transferring moment of inertia parallelly. Right? Next we have perpendicular axis theorem. Perpendicular axis theorem, many students will get confusion here. This is a one x-axis and this is called as a perpendicular. No, this is not perpendicular axis to this one. Perpendicular means perpendicular to the sheet, that I cannot show it here. Okay, perpendicular to the sheet. If I want to show in a three-dimensional, you can see here, this is the sheet. Correct? Three-dimensional sheet, and perpendicular axis andre this is your perpendicular axis. Okay, this is your perpendicular axis, perpendicular to the plane. Okay, they are talking about perpendicular axis theorem. Okay, now how to get a perpendicular axis moment of inertia? See, every, again I am repeating, every area will have its own moment of inertia in central axis. Correct? Means we will be having ixx in xx axis and iyy in yy axis. If I add these two, then I will get a izz axis. Zz means this is z, z. Z is a perpendicular axis. Okay. In this diagram I cannot show. Here I can show it. Correct? That is your adding xx, adding yy will give you zz. Okay, usually we have a notation. J means there is a perpendicular axis and I is a central either x-axis or y-axis. Right? J is a moment of inertia in central axis, perpendicular, that is a polar axis. We have another name called as a polar axis. Like this looks like a pole, no? This look like a pole which is inserted in the section. Okay, now why they want to call it as a J? Just it is a funny thing, that is I is already used now, therefore the next alphabet J they are going to use it for polar moment. That's it. Okay. Now we will study moment of inertia for some common area. Before studying moment of inertia for common area, we will study center of gravity for regular sections. Okay, now look at it. Okay, do you have any doubts in concept? If you have anything to ask in the concept, you can ask.
Sir, perpendicular axis theorem ಎದಕ್ಕೆ ಯೂಸ್ ಮಾಡ್ತಾರೆ ಸರ್?
Perpendicular theorem axis ಎದಕ್ಕೆ use ಮಾಡ್ತಾರೆ? One ನಿಮಿಷ. Now you can concentrate on video. Concentrate on my video. That is very important. ಇದು ಆಫ್ ಮಾಡ್ಲೇನಾ? Okay, now look at here. This is the one plane. Correct? Moment of inertia is all about rotation. Moment of inertia is all about rotation. See, this is a one axis. This is one axis and which is able to rotate about this axis. Then moment of inertia, jerk. Jerk enga? Jerk. Right? This is a moment of inertia about x axis. Right? Now moment of inertia about y axis ಅಂತಂದ್ರೆ this is your moment of inertia in y axis. Correct? Now moment of inertia about base axis ಅಂತಂದ್ರೆ moment of inertia about base axis means, see, this is a base axis, then this is a moment of inertia about base axis. You had a moment of inertia here and that you transferred to here, therefore your notebook is about this pad is about to rotate about x axis. Then if you want to rotate it like this, then you can rotate it like this, like that. Now you ask the question, why we want polar axis? Polar axis means perpendicular axis. Perpendicular means your notebook is about to rotate it like this. Okay, means if you have any pole like this and you want to rotate about a polar axis, then moment of inertia will come into picture. That is your perpendicular axis theorem. ಎಲ್ಲಿ ಬರ್ತದ ಪ್ರಾಕ್ಟಿಕಲ್ ಅಂದ್ರೆ ಕಾಲಮ್ಸ್ ಒಳಗಡೆ, because columns will be like this, no planes, there will be many planes will be like this, then the column may bend like this, column may bend like this, or column may twist. Okay? Beam adapa, this beam is made up of many planes, then beam is subjected to torsion, and torsion bantandra this will rotate like this. Okay, twist agtade, this beam will twist. How it will twist, it will twist in a perpendicular axis. That's why whenever you study torsion chapter, their moment, polar moment of inertia will come. Whenever you study this bending moment and shear force, only moment of inertia will come. Understood?
Yes, sir.
Any other doubts in concepts? Okay, we'll go ahead. Okay, we'll go ahead. Now, moment of area, that is CG, we will just, you already know, but still I will be drawing few areas. Let us consider this is a square and this is your center. This is A distance, this is A distance. Then the center is appeared at a distance A by 2 from here, and that is appeared at a distance A by 2 from bottom. This you know. And if a rectangle is there, if rectangle is there, then rectangle, this will be height. Then this, if you consider it as a D, then this is a D by 2, and if you consider this as a B, then this is B by 2. Correct? This is B by 2 and this is D by 2. This you know. Then if it is a triangle, in triangle I will draw some many type of triangle. Look at here, you remember this is a rectangle, right angle triangle. Right angle triangle, this is a 90 degree. Near to 90 degree you have to draw this one point, and that point, the small distance is 1/3 of the height base, and the big distance is 2/3 of the base. Like that, height also, this is 1/3 of the height, and this is a 2/3 of the height. Okay, now 1 minute, I will put a charge. This is one type of triangle. The another type of triangle, we will be having some symmetric triangle. This is symmetric triangle. Symmetric triangle means this is symmetric about this axis. Then you will be having a CG in the symmetric axis. If this is your base, then this is your B by 2. This is B by 2. Then the height, if this is the total is a H, then this height is H by 3. That is 1/3 of H. And the height is, this one is 2/3 of H. Okay, now then we have another type of triangle, that is unsymmetric triangle. Very interesting. This is A distance and this is the B distance. Then the CG of this one will be, let us consider. This total distance is L, and the height is H. Then in this case, Remember, CG will not be in this axis, it will be somewhere here. Then that distance from here to here is L plus A by 3, and from here to here is L plus B by 3. Then this height is H by 3, 1/3 of height, and this one is 2/3 of height. Okay, this is unsymmetric triangle. Next, we have a circle. This is a circle, and of course circle will be, this is a d by 2. In any way you can consider it as a d by 2, that is radius. Then this is your diameter. Okay, now if we have a semicircle, then you will be having CG here. Then this one is 4r by 3 pi, 4r by 3 pi. You remember this one. Okay, and the total is r. This is your r, semicircle. Then if you have a quadral circle, then near to the right angle you will be having the CG. Then the height is this distance is 4r by 3 pi, and this height is 4r by 3 pi, 4r by 3 pi. Of course, this is your r distance. Right? Now these are all your regular sections, that is a square, rectangular, triangle, three types, and circular, semicircular, and quarter circle. Then after that you will be having some other sections like composite sections. Composite sections andra two rectangles makes one T section, three rectangles makes one I section, two rectangles make L section, three rectangles make channel section, or you will be having one rectangle and one semicircle, or you can have rectangle and triangle, or you can have dam section. Okay, now I'm getting little sense in the syllabus. Now go here, why they have included these terms, no, chimney, dams, and retaining walls. You know, these words are here. I don't know the exact meaning why they are here, but I can predict something like, you can determine CG of chimney. Chimney will be something like this. This is a chimney, or sometimes with a dome. Okay, or something like this. This is a chimney. Okay, or this is also chimney. Okay, and maybe you want to determine center of gravity. Retaining walls, they have said, means the retaining wall will be something like this. You can determine center of gravity of retaining wall. Okay, or sometimes retaining wall will be something like this. Dams, they have said, you know, dams and somewhat the shape is somewhat same. We can consider it dam dam section, or you can consider um, earthen dams like this, you know. Might be they are talking about compound sections. And even see, this is semicircle, this is another semicircle, this is another semicircle. Okay, this is also one shape. Like that we have many shapes which are composed by simple sections. Okay, for them, what you need to do? For them, divide a whole area into parts, then call them as a A1, A2, A3 as a area, and Y1, Y2, Y3 as a local local perpendicular distance, or CG distance, X in Y direction and in the X direction. Then you can determine Y bar using equation A1 Y1 plus A2 Y2 plus A3 Y3, so on, divided by capital A, total area. Or you can determine X bar equal to A1 x1 plus A2 x2 plus like that divided by total area. This is a determination of moment of area ಅಥವಾ CG or centroid for composite sections. Right? Now we have completed moment of area. We will go to moment of inertia. Okay. Now look at here. This is moment of inertia. Moment of inertia for rectangular section. Moment of inertia for rectangular section is BHQ by 12 or BDQ by 12. You know, look at it. This is rectangle. This is your centroidal axis X X, and this is also centroidal axis Y Y. Therefore, IXX is BDQ by 12. IYY is DBQ by 12. Okay, always you remember cube will be perpendicular distance, that is your D. Just you can remember. Now if you want moment of inertia of base, this is IBB. If you want IBB, then what we have to do? That is your IGXX plus area into H square. IXX is BDQ by 12 plus area is B into D, and H, height is distance between where you want to transfer, that is your D by 2. Then if you do, then you will get BDQ by 3. Right? You solve it later. Right? Now you can, we will see the diagram here. This is your BHQ, BHQ or BDQ by 12, and IYY is HBQ by 12. Then polar moment of inertia means adding IXX and IYY, you will get this one. Then moment of inertia about base. Base they have called it as INN, and that INN equal to IXX plus area into distance square. Then that is BHQ by 3. Then square. Square means what? This and this is same, both are same. Therefore BD cube by 12 is already there, B equal to D, therefore D power 4 by 12 or A power 4 by 12. This is your square section. Interestingly, square area with the diagonal axis also we will get A cube, A power 4 by 12. IXX, this is IXX. Then IYY is also same for square. Okay, diamond, this is called as a diamond. Square axis with axis parallel to the x-axis or diamond section, next rectangular hollow section. This portion is there, okay, but inside portion is not there, just it is minus. Capital B for the big outer side and small b and small h for the inner side, and make it minus, that's it. Now we'll come to the circular sections. This is a circular section. This is your circular section. Now circular section about this axis, central axis xx, xx. Therefore Ixx equal to pi d power 4 by 64. Pi d power 4 by 64. Both are same. Ixx and Iyy both are same. Therefore this one. Then what about this one Ijj or j? Polar moment, that is your Ixx plus Iyy. Then you add this one and this one, then you will get pi d power 4 by 32. Pi d power 4 by 32. Now moment of inertia of a circular area with concentric hole. Concentric hole means only we have this much of area, inside area is not there, therefore you just minus it. Outer diameter capital D, inner diameter small d. But very important is power 4 will be like this. Don't do like this. See here, many students will write it like this, wrong. 32, like d minus d whole power 4. This is wrong. Okay, this is right. Okay, now very interesting. Semicircle, moment of inertia about central axis, very interesting. X axis is different, moment of inertia about n axis is different. Here we will get different, right? X is there and n is there. It is very easy to remember INN base, that is where half of the circle. Half of the circle means pi d power 4 by 64 is already there. Half of that one means pi d power 4 by 128. Right? This is I half of it. Then from this we will indirectly we will calculate IXX. IXX later we will get it. IXX we will get it like this one. That is your 0.11 R power 4. You remember like this only. Okay, this you have to by heart, or exam before day, that day you have to by heart. Now quarter circle, for that quarter circle IXX is this one, 0.055 R power 4. Okay, and INN is, this is wrong, this is wrong, half of pi d power 4 by 128, that is your pi d power 4 by 256. Okay, for quarter circle, this one. Okay. Now in triangle, this is a central axis IXX, that is your BD cube or BH cube by 36. 36, very interesting. And if you want at the base level moment of inertia, then that is BH cube by 12. BH cube by 12. Okay. Now circle, this is a ring, it is not circle. Don't confuse. This is your bangle. Bangle with a very small thickness t. Then what is the moment of inertia of your bangle? That bangle moment of inertia is pi r cube t. Pi r cube t, that is about perpendicular axis. Sorry, IXX and IYY, that. Okay, next the same thing bangle, but this bangle is elliptical bangle, then pi a b cube by 4. By heart this thing. Okay. Then after that we will get a radius of gyration. In syllabus it is not mentioned. B students, you might be knowing this one, you can study. It's nothing, just a radius of gyration. We have one term called as KXX, that is your root of IXX by A. Okay. IXX you already know, moment of inertia about x-axis, and A is a area, the entire area. Okay. Like that you can have kxx, like that you can have kyy, moment of this is a radius of gyration. Okay. Radius of gyration in z axis also you can have k naught, that is j by a. Okay, over. This much is a moment of inertia and CG. Right? Any doubt? Okay, we'll go ahead. Now I will complete another, I will take another chapter, because today's target is 3 chapters. This moment of inertia and CG questions we will solve later. Coming to bending stress in beams. Okay. Okay. So take some 3 minutes or 4 minutes gap, because your brain should not get confusion with moment of inertia and this one. You should have some fresh mind to study moment of inertia. That's right. Bending stress and shear stress. ಓಕೆ, ಗ್ಯಾಪ್ ನಿಮ್ಮ ಬ್ರೈನ್ ಒಂದು ಸ್ವಲ್ಪ ಫ್ರೆಶ್ ಆಗ್ಲಿಕ್ಕೋಸ್ಕರ ನಾವೇನು ಮಾಡೋಣ, ಎ ಬಿ ಸಿ ಡಿ ಉಲ್ಟಾ ಬರೆಯೋಣ. ಜೆಡ್, ವೈ, ಎಕ್ಸ್ ಅನ್ಕೊಂತ ಹೋಗ್ರಿ ಮನಸ್ಸೊಳಗೆ. ಎಕ್ಸ್ ಆದ್ಮ್ಯಾಗ ಡಬ್ಲ್ಯೂ, ತಪ್ಪ ಮಾಡಿದ್ರೆ ಹೇಳ್ಬೇಕು. ಎಕ್ಸ್ ವೈ ಜೆಡ್ ವೈ ಎಕ್ಸ್ ಡಬ್ಲ್ಯೂ ವಿ ಅಲ್ಲ ಯು ವಿ ವಿ ಯು ಎಸ್ ಟಿ ಎಸ್ ಆರ್ ಪಿ ಕ್ಯೂ ಪಿ ದೆನ್ ಓ
O,
ಓ ಎನ್ ಎಂ
M,
ಎಲ್ ಎಲ್ ಜೆ ಜೆ
K sir, K.
ಕೆ ಎಲ್ ಎಲ್ ಕೆ ಎಲ್ ಕೆ ಜೆ ಐ ಐ
H.
ಎಚ್ ಜಿ ಇ ಫಾಸ್ಟ್ ಆಗ್ತೈತಿ. ಎಫ್ ಅಲ್ಲ ಎಫ್
F sir.
ಎಫ್ ಇ ಡಿ ಸಿ ಬಿ ಎ. ಕರೆಕ್ಟಾ? ವೆರಿ ಗುಡ್. ಓಕೆ, ನಿಮ್ಮ ಎಲ್ಲ ಹೆಸರನ್ನ ಬರ್ಕೊಡ್ರಿ. ನಿಮ್ಮ ಹೆಸರನ್ನ ಎಷ್ಟನೇದಿದು? 1 2 3 4 5 ಬೇಡ, ಇಲ್ಲಿ ಬೇಡ, ಉಲ್ಟಾ 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17 18 19 20 21 22 23 24 25 something we missed. A B C.
Sir, ಎಲ್ಲದರ ನಂಬರ್ ಹಾಕಿರಿ ಸರ್.
Correct. 11, this is 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 27, 26, 27. ಎಷ್ಟದು ಆಲ್ಫಾಬೆಟ್? 26
Sir,
26.
sir, double ಆಗೋಣ U ಇದೆಯಲ್ಲ ಅದು ರಾಂಗ್ ಇದೆ ಸರ್, ಅಲ್ಲಿ ಹಾಕ್ಬೇಡಿ.
ಡಬ್ಲ್ಯೂ ಆಗೋಣ ಯು. ಓ ಕರೆಕ್ಟ್. ಒಂದು ಸೆಕೆಂಡ್. ಓಕೆ, 21, 22, 23, 24, 25, 26. ಕರೆಕ್ಟಾ? ನಿಮ್ಮ ಹೆಸರು ಬರ್ಕೊಡ್ರಿ. ನಾನು ನನ್ನ ಹೆಸರು ಬರಿತೀನಿ ನೋಡು. ಆರ್ ಎ ಜೆ ಎ ಎಸ್ ಎಚ್ ಇ ಕೆ ಎಚ್ ಎ ಆರ್. ಆರ್ ಅಂದರೆ 18, 1, 10, 1, ಎಸ್ 19, ಎಚ್ 8, ಇ 5, ಕೆ 11, ಎಚ್ 8, 1, 18. ಟೋಟಲ್ this is the power of Rajshekhar, you know. Okay, now fresh ada martri alla CGMI. Now we'll go with the next concept. ಮರ್ತ್ರೆ ಅಂದ್ರೆ ಪೂರ ಮರಿಬಾರ್ದ, ಜಸ್ಟ್ ಲಿಂಕ್ ಇಟ್ಕೋಬಾರ್ದು. ಈಗ ಹೊಸದಾಗಿ ಫ್ರೆಶ್ ಆಗಿ ಸ್ಟಾರ್ಟ್ ಮಾಡ್ರಿ. ಯಾರಾದ್ರಿ 100 ದಾಟಿ ಹೋಗ್ಬಾರ್ದು, 100 ಇರ್ಬೇಕು. ಓಕೆ, ನೌ ವಿಲ್ ಸ್ಟಾರ್ಟ್ ವಿತ್ ದ ಕಾನ್ಸೆಪ್ಟ್. See, Stress means that is the internal resistance offered by the body. Internal resistance offered by the body is called as stress. Okay, na? Okay. Internal resistance offered by which type of which nature? Okay. See, if a body is there like this, and if you pull, then this is a tension. Internal resistance offered for the tension is called as tensile stress. Tensile stress. Then internal resistance offered by the compressive nature, compre- compressive stress. Internal resistance offered by the material for the shear, then shear stress. Like that, internal resistance offered by the bending. Internal resistance offered by the bending is called as bending stress. Okay. Now look at here. I have a two way to bend any material. The first way is, this is a rod and I will apply some load here and I will apply some load here. Moment. See, this is moment and this is moment. When I apply moment this side and this side, then this bar will bend like this. Very interesting. Correct? It will bend like this. Now I have another way to bend the bar. Let us consider this is a bar and one support here, and one force here. When I apply this force, then also bar will bend. What is the difference between this bend and that bend? Any doubt? Any suggestion? What is the difference between this type of bend and this type of bend?
Sir, first one is the rotation load, second one is point load.
First one is the rotational load and second one is the point load. Okay, means we can bend any material not only by rotation, by applying some perpendicular loads. They are called as transverse loads. Transverse loads. Transverse loads means your axis of the member is here and you are applying loads perpendicular to the axis of the member. Loads are applied perpendicular to the axis, therefore they are called as a transverse loads. Correct? But here we are applying momentary loads, that is moments, then we are bending. That's why this is called as flexure. This is flexure and this is bending. Correct? Flexure means the result of the flexure is also bend. Bending is also bend. But in flexure, we are applying transverse force and bending. And in bending, we are applying moments and bending. Then, what will be the this one project, not project, profile of the bend? The profile of sorry, one more thing. This type of bend is there, no? Applying moment and bending is called as pure bending. Why it is called as a pure bending? Any idea? Why it is called pure bending? Okay, don't worry, I will explain. Now look at here. Let us consider a cantilever. Cantilever subjected to moment at one end. Then what is the reaction in the support? The reaction in the support is also moment. Now see, this is moment and this is moment. Both moments will bend the material this way. Then, very interestingly, cantilever, cantilever subjected to moment at free end. Moment at free end will result pure bending. Agree? Will result pure bending. Why it is called pure bending? Because in this diagram, if I draw shear force diagram, then shear force diagram is no shear force. Shear force diagram is just line. Okay, no shear force or no SFD will come. Therefore, this beam is subjected to only bending and it is bent. Only bending and it is bent. Therefore, this is pure. It is pure. There is no shear, there is no other type of internal stresses developed in this type of beam. Therefore, it is pure. Then in this case, in a simply supported beam with the transverse loads, then this also bends. This also bends. But in this case, you have inside the body shear force is also there and bending moment is also there. Means the body will resist shear also, the body will resist bending also. Then after that it will bend. Therefore, this is not a pure bending, not pure, not pure. Therefore, this is called as a flexure. Flexure. The word it is from other country, it is flexure. Now, when the pure bending is occurred, when pure bending is there, then the profile of a bend, profile of a bend is arc of a circle, arc of a circle, or circular arc. Means this bend is there, no? This is like this. It is bent, no? Then if you complete, then you will get a circle. But when transverse force are applied, then this bend is there, no? This is not a arc of a circle. This will never combine. Like, it may be parabola, it may be hyperbola, it may be ellipse, it may be logarithmic, whatever it is not a circle, arc of a circle. Therefore, this is flexure or not pure. In pure, we will be having always arc of a circle. It might be this way or it might be this way, but whenever there is a bend, that if you can complete, then you will get a circle. Understood? Now you understood the meaning of conclusion. You understood the meaning of pure bending. Pure bending means no transverse loads, no transverse loads, and no transverse loads means no shear, no shear. Therefore, it is called pure bending, and you will get a arc of a circle, arc of a circle. When you get a arc of a circle, means let us consider this is a profile of the bend, and if you complete this one, then you will get a circle. Then you will be having a radius. You will be having a radius for this one. Then this is called as a radius, and this is called as radius of curvature. Radius of curvature. Correct? This is the radius of curvature. Now you got a meaning. Look at here. The beam is there. This beam is bent. Why it is bent? Because bending moment is there. That I will call it as a M. And when after bending this one, it will have radius of gyration. Radius of curvature. That is considered as R. Correct? Now, when it bends now, then inside some stress will develop. That stress is called as F, bending stress. Okay, and we will be having some geometric properties like I and Y, and all together, and material property like E. See here, this is geometric property, geometric property, and this is material property, material property, and these are all bending moment and stresses and strains are response and stimulus. Then combining all of them, we will have a equation, this one, that is F. We can call it as a F. This is F by Y equal to M by I equal to E by R. Usually we will call it as a may I follow you, Elizabeth Rani. No? Like that also we can remember. M by I equal to F by Y equal to E by R. All are there here. Right? This equation, we have to read it like this. M by I, one equation, and M by I is equal to E by R, another equation, or F by Y is equal to E by R, another equation. Like that we will have three equations and we can solve any problems. Okay now? Now very important, assumptions of simple bending theory. See, simple bending theory or pure bending theory, both are same. Shear force at each point, each cross section is zero. You got it already. Normal stress due to the bending is only produced. Beams are initially straight. This is common sense. Material is homogeneous, isotropic everywhere. It has a uniform composition and mechanical property and same in all directions. The stress strain relationship is linear and elastic. Okay. What is the meaning of linear and elastic? Stress strain relation means we already studied this Young's stress strain curve. Means this chapter, which chapter? Bending stress chapter is valid from here to here. This chapter is valid from here to here. Why? Because the stress strain is linear line aithe, and elastic because here elastic point is there. Okay, that assumption is there. Means when I consider this one, then I can say that Hooke's law is valid. Hooke's law, because Hooke's law is also from here to here. Therefore, Hooke's law is valid. Young's modulus is same in tension and compression. That is always. Section are symmetric about the plane of bending. Sections are symmetrical about the plane of bending. Then sections which are plane before the bending and after the bending will be plane only. Very important assumption. Very important assumption. Means this this is your section, and after bend, first I will tell you what is the what happens when it bends. Look at here, this is your beam and it has a many bars like this, assumed, many bars like this. Then when it bends it will be like this, right? Then if I concentrate one bar, that is like that, that bar here becomes like that. Earlier also it was a straight and plane, and after bend also it become straight and plane. That is this assumption. Okay, here this assumption is based on linear strain theory. This question they will ask many times, strain theory. In gate exam they have asked this question many times. Okay, they will ask on what basis this assumption is made. Sections which are plane before bending and bending remain plane after bending, on what basis they have assumed? They have assumed it on this basis, that is linear stress strain theory, or vice versa. Okay, then we have a derivation here. They will derive this one, and after that we have, I will write again once again. I will take this example. Now look at here. For diploma level, you remember all these. M by I equal to F by Y equal to E by R. Now, M by I equal to F by Y. One equation. Another equation is M by I equal to E by R. Another equation is F by Y equal to E by R. Now look at here. M equal to, sorry, F equal to M by I into Y. M by I into Y. Then F equal to M by I by Y we can write. Right? This Y will come down. Then F equal to M by Z we can call. Where Z is section modulus. Section modulus. Right? Now, one more thing. Now, this F power is 1 and Y power is 1. Therefore, stress variation is also linear. Is also linear. Very important. Right? Now, F is inversely proportional to Z. Right? F means what? Stress. F is stress. We have another equation. Stress is inversely proportional to strength. Strength. From this we can infer that strength is directly proportional to Z. Very interesting. As Z increases, strength increases. Strength increases. As Z increases, strength increases. Very interesting. Now, this is a beam 50 by 100 cross section of the beam. This is another beam 50 by 100. Which beam will be having more strength? Anyone? Can anyone tell? This is one beam. Supports, supports. Another beam is like this. Which beam will be having more strength?
Second one.
Huh? Which beam? A.
Second one.
First one.
Second one.
Second one will be having more strength. Why? Because here depth is more. What happens if depth is more? If depth is more, then d cube is more. Correct? Huh? Depth is more, then d cube is more. You know? Then b d cube by 12 is your I. Means I is more. If I is more, z equal to I by y. Then I is more means z is more. If z is more means strength is more. Right? Huh? Now, in other case, b is less. Therefore, bd cube by 12, in that one b we have only one power. Therefore, I will be compared to less. Therefore, z is less. Therefore, strength is less. That's why always depth should be more than the breadth to have a good strength. This is one example. Later you can discuss many things. One beam like this, another beam like this, or you discuss like this. Now tell me, which will be more strength? A square and circle of same height. Which is more strength? 1 and 2. Can anyone tell? Hmm.
As a circle.
Circle is more strength? No. This is more strength. Why? Just you calculate I for the square and y for the square, and calculate I for the circle, y for the circle. Then you check z, check z. Then obviously this z will be more. Therefore this will be good strength, and this will be less. Therefore this will be less strength. Right? This is all about this side. Okay, na? Now we'll come to this side, other side. M by I equal to E by R. Okay. Here we will see M by M equal to EI. Sorry, M by EI equal to R. Sorry, 1 by R. Or 1 by R. Okay. Or you call it like this. M equal to EI by R. Correct? Okay, in a previous class, in yesterday's class, we I told you something like Y is deflection. Correct? Then dy by dx is theta slope. Then d cube y d square y by dx square is moment. Right? Now d square y by dx square is moment means may I write it like this here? That is your d square y by dx square. Means 1 by r is nothing but d square y by dx square. That's why it is called as curvature. This will yield Macaulay's theorem. Macaulay's theorem or double integration method. What the double integration method. Why it is double integration method? Because d square y by dx square, if you integrate once it will give dy by dx, if you integrate once then it will give y, means from this you can determine deflection, slope and deflection methods, slope and deflection methods. Which one? Double integration method, Macaulay's method. Okay, that will come from here. Next, coming to this one, and one more thing, this ei is there, no, this is called as a flexural rigidity, flexural rigidity, flexural rigidity. Then flexural rigidity, I will write here, strength, strength is directly proportional to ei. As flexural rigidity increases, strength increases again, more wala. If d is more, d cube is more, d cube is more, then therefore I is more, I is more means z is more, z is more means strength is more, then I is more means ei is more, ei is more means strength is more. That's why this beam wins, this beam wins in two concepts. One, it has a more ei and it has a more z value, therefore this beam will win, right? Now coming to this side, f by y equal to e by r, f equal to y by r into e, f equal to, now concentrate on this bracket, what you can see here. Now come to here, in assumptions I have made this assumption, that is stress strain relationship is linear and elastic, therefore Hooke's law is valid because we have considered this part, then Hooke's law is valid. Okay. Hooke's law valid now. Hooke's law means what? Stress is directly proportional to strain, stress is equal to Young's modulus into strain. Now this is Young's modulus, this is Young's modulus, this is strain, then this is strain, this is stress, this is stress, therefore strain is equal to y by r. Conclusion, strain equal to y by r, right? See, this all the things we can remember from bending stress theory. This is all it is included here, everything is covered here, you can go through, and they have calculated z value, just by heart these things. Okay. Then after that, flexural rigidity I explained. This is axial rigidity. Always see here, I will give you three terms. ei is a flexural rigidity. ಫ್ಲೆಕ್ಚರಲ್ ಅಂದ್ರೆ ಏನು? ಬೆಂಡ್, ಹೌದಾ? ಬೆಂಡಿಂಗ್ ಆಗಬಾರ್ದು ಅಂತೇಳಿ ಅದು ರಿಜಿಡ್ ಮಾಡೈತಿ. ಫ್ಲೆಕ್ಚರಲ್ ರಿಜಿಡಿಟಿ, ಬೆಂಡ್ ಆಗಬಾರ್ದಪ್ಪ ಅಂತೇಳಿ ರಿಜಿಡ್ ಐತದ, ದಟ್ ಈಸ್ ಯುವರ್ ಇ ಐ. ಇ ಎ ಅಂತಂದ್ರ ಆಕ್ಸಿಯಲ್ ರಿಜಿಡಿಟಿ ಅಂತಾರೆ. ಆಕ್ಸಿಯಲ್ ರಿಜಿಡ್ ಅಂದ್ರೆ ಆಕ್ಸಿಯಲಿ ಉದ್ದ ಅಗಲ ಆಗಬಾರ್ದಂತ, ಎಕ್ಸ್ಪ್ಯಾಂಡ್ ಅಂಡ್ ಕಂಟ್ರಾಕ್ಷನ್ ಶುಡ್ ನಾಟ್ ಹ್ಯಾಪನ್. ಆಕ್ಸಿಯಲಿ ಅಗಲ ಆಗಬಾರ್ದು, ಆಕ್ಸಿಯಲಿ ಕಂಪ್ರೆಸ್ ಆಗಬಾರ್ದು, ಅಂದ್ರೆ ಆಕ್ಸಿಯಲಿ ರಿಜಿಡ್ ಇರ್ಬೇಕು, ದಟ್ ಈಸ್ ಯುವರ್ ಇ ಎ. ಫ್ಲೆಕ್ಚರಲ್ಲಿ ಆಗಬಾರ್ದು ಅಂದ್ರೆ ಇ ಐ. ನೆಕ್ಸ್ಟ್ ಈ ಜಾಗದೊಳಗೆ ಜಿ ಬರಿತೀನಿ, ಐ ಜಾಗದೊಳಗಡೆ ಜೆ ಬರಿತೀನಿ, ಕರೆಕ್ಟಾ? ಜಿ ಜೆ ಆರ್ ಜೆ ಜಿ. ದಿಸ್ ಈಸ್ ಕಾಲ್ಡ್ ಆಸ್ ಅ ಟಾರ್ಷನಲ್ ರಿಜಿಡಿಟಿ. ಮುಂದಿನ ಚಾಪ್ಟರ್ ಒಳಗೆ ಬರುತ್ತೆ ಟಾರ್ಷನಲ್ ರಿಜಿಡಿಟಿ. ರಿಜಿಡಿಟಿ ಅಂದ್ರ ಟ್ವಿಸ್ಟ್ ಆಗಬಾರ್ದು ಅಂದ್ರ ಜಿ ಜೆ, ಉದ್ದ ಅಗಲ ಆಗಬಾರ್ದು ಅಂದ್ರ ಇ ಎ, ಬೆಂಡ್ ಆಗಬಾರ್ದು ಅಂದ್ರ ಇ ಐ. ಫ್ಲೆಕ್ಚರಲ್ ರಿಜಿಡಿಟಿ, ಆಕ್ಸಿಯಲ್ ರಿಜಿಡಿಟಿ, ಟಾರ್ಷನಲ್ ರಿಜಿಡಿಟಿ. Remember this. Okay. Now uniform beam strength. To have a uniform beam strength, m is directly proportional to bh square. ಇದು ದೊಡ್ಡ ಕಾನ್ಸೆಪ್ಟ್ ಐತಿ, ಇದ್ರೊಳಗೆ ಎಷ್ಟೈತೆ ಅಷ್ಟೇ ಹೋಗ್ಬಿಡ್ರಿ ಸರ್. ಬೆಂಡಿಂಗ್ ಸ್ಟ್ರೆಸ್ ಡ್ಯೂ ಟು ಆಕ್ಸಿಯಲ್ ಥ್ರಸ್ಟ್, axial thrust. Okay, bending stress due to axial stress thrust. Axial thrust andre, see this is a member, Correct? Huh? Now I am applying this force. When I apply this force, will it bend? No, it will not bend. Then I am applying either bending moment or transfer load. When I apply this force and axial force, then this material will bend. Okay? Na? When it bends inside, this is bent because of P, this is bent because of moment M. Correct? ಎರಡರಿಂದನೂ bend ಆಗಿದೆ. Then inside what has happened is called as bending stress due to axial thrust. Bending stress due to axial thrust. Now that equation is this one. At the top fiber, it is P by A M into Y by I. Bottom fiber P by A into M by I is this minus. Okay, because this and it will bend like this now. Then top one is compression and the bottom one is tension. This is compression tension. Okay, bottom fiber uh, bottom fiber compression, top fiber, no, this is tension, and top fiber compression, mid fiber compression. Why? Because we have this also, no, that's why. Okay, next, load acting eccentrically to one axis. Now very interesting, look at here. I will draw three diagrams. You have to tell me the result, what happens in that beam. Okay, concentrate. Now we'll take a blue color. Now look at, in the first diagram, the force is like this and the force is like this, and in the second diagram the force is like this and another force is like this. In the third diagram the force is like this and the force is like this. What happens? First one, what happens? Hmm.
Compression.
First one is pure compression. Second one,
Shear.
second one is shear, because one force just above the axis and one force just below the axis, therefore shear. Third force, third diagram,
Bending.
very good. Okay, in the third diagram, eccentric bending another. This is called as eccentrical, load acting eccentrically. Some distance is there now here. This distance is called as E, small distance. Because of this, the material will bend like this. Okay, ಇದು ಇಲ್ಲಿತ್ತಲ್ಲ. Okay, this will bend. That's why in bending chapter, we are discussing about bending chapter. In bending chapter, they have included eccentric. Okay, now just you remember, see here, sigma is considered where moment is not there. Is there any moment in this equation? No, but moment acted because of P into E. This is your force P and this is force E. P into E will cause a moment at this point. That small moment I have considered, but external moment is not there. Then this is sigma max. Like that, sigma minimum is P by E. Correct? I'll draw another figure to understand this one. Now look at here. This is some beam or some column. We will consider column. This is your center axis. If the force is uniform force or Q force is here, Q force is acting, then the stress distribution is, this is your stress. Then this is Q means this distance is Q by A. This distance is Q by A. Both are Q by A. Okay, now if that q shifts here, if q is shifted here, then diagram will be more this side, less this side. Agree? More stress this side and less stress this side. Okay, now what about this? That is q by a plus qe by qe by, where is that, qe by I into y, qe into y by I. Then what about this? This is minus q by a minus qe by y by I. Right? Now, interesting. Another interesting is, if this load shifts further, then that load shifts further means this becomes more, very more. Then this becomes 0. When this becomes 0 means this is 0. This is same q by a plus qe by I into y. Okay. Now another very interesting is, if this q is further shifted this side, q is further shifted this side, then what happens? Then this become negative and this become positive. This is tension and this is compression. Right? Okay. Now means there is a limit. This is a beam means, this is the center means, if you apply load here, compression, eccentric with E, okay, little more compression and less compression, one side more and one side less. Then again here, more compression one side and very less compression other side. Then if you shift your E this side, then more compression one side and zero compression at other side. Then if you shift again, then what happens? One side compression and other side tension. Then this distance is there, no, this is called as E max. This distance is called as E max. Correct? That is E max. That's why how to get this E max? That is your condition for no tension in any section. No tension in any section. You remember this one. To have no section, this E max must be less than h by 6 or 2e equal to h by 3. You remember this. Correct? Over. This is bending stress chapter. Any doubt?
Sir, ಅದು ಲಾಸ್ಟ್ ಡಯಾಗ್ರಾಮ್ದಾಗ y ಏನ್ ತಿಳಿಲಿಲ್ಲ ಸರ್. y by I.
Y by I ತಿಳಿಲಿಲ್ಲ. 1 minute. See, I will show it here. We have m by I equal to f by y. Correct? F equal to m by I into y. Then if you have any beam or column like this, then if your load P is here and E is here, correct? One more diagram. See here. This is P now. Okay. Now I want to transfer this P to this point. This P I want to transfer here. To transfer that, what I have to do? I will make some arrangement. Arrangement is one P this side and another P this side. Correct? Now this P and this P will make a moment with eccentric E. Andre, the result of this diagram will be 1P and another moment. Correct? This moment is how much? That is your P into E. That P into E I will substitute here. That is F equal to P into E divided by I into Y. This Y and I came from where? Bending equation. Correct? I is the definition ಆಮೇಲೆ ಹೇಳ್ತೀನಿ. Okay. Now we have two type of stress in this one. The one stress is P by PE, that is this one. Another stress is P by A. This is this P and by A, one stress, and another stress is PE by I into Y. Now your question is, from where, how we got Y you got, no? From the bending equation linda Y bant. Okay. But Y the meaning ಏನಂತಂದ್ರ, if this is a neutral axis, then extreme fiber distance ಗೆ Y ಅಂತ ಕರಿತೀವಿ. That is, Y is a distance between neutral axis and fiber interested or extreme fiber. ಓಕೆನಾ? ಎರಡು ಡೆಫಿನಿಷನ್ ಕೊಟ್ಟೆ. Y ಅಂದ್ರ ಬೆಂಡಿಂಗ್ ಇಕ್ವೇಶನ್ ಇಂದ ಬಂದದ, ಮತ್ತು Y ಅಂದ್ರ ಡಿಸ್ಟೆನ್ಸ್ ಬಿಟ್ವೀನ್ ನ್ಯೂಟ್ರಲ್ ಆಕ್ಸಿಸ್ ಅಂಡ್ ಫೈಬರ್ ಇಂಟ್ರೆಸ್ಟೆಡ್. ಹೋಪ್ ಅಂಡರ್ಸ್ಟುಡ್. Any doubt? Others?
No, sir.
Others, any doubt? Okay. ಇವತ್ತು ಕ್ವಶನ್ ಸಾಲ್ವ್ ಮಾಡಕ್ ಟೈಮ್ ಸಿಗ್ತಾ ಇಲ್ಲ, ರೈಟಾ? ನಾವು ವಿಲ್ ಗೋ ಟು, ಈಗೇನ್ ಮಾಡೋಣ, ಕನ್ನಡ ಉಲ್ಟಾ ಹೇಳೋಣ ಈಗ ಒಂದು ಸ್ವಲ್ಪ. ನೆಕ್ಸ್ಟ್ ಚಾಪ್ಟರ್ಗೆ ಹೋಗ್ಬೇಕೀಗ. ಐ ಇ ಬೇಡ, ಜ್ಞ ಕ್ಷಜ್ಞ ಕ್ಷ ಳ ಹ ಕ್ಷ ಜ್ಞ ಕ್ಷ ಳ ಹ ಹೇಳ್ರು, ಬರವಲ್ತ ನನಗ.
ಸರ್ ಸರ್
ಸ ಶ ಸ ಶ, ದೊಡ್ಡ ಶ, ಕರೆಕ್ಟಾ? ಶ ಶ ಸ, ಉಲ್ಟಾ ಬರೆಯಕತ್ತೀವಿ ಅಂದ್ರೆ ಉಲ್ಟಾನ ಬರ್ಬೇಕು. ಮಿರರ್
Sir, sure adna was sir. Sun sure adna was sir.
ವ ಬರ್ತೈತಿ, ವ
Ho admak sir ಬರುತ್ತೆ ಸರ್.
ಆದ್ಮೇಲೆ ಸ. ನೆಕ್ಸ್ಟ್ ಇಲ್ಲಿ ಕರೆಕ್ಟ್ ಐತಿ, ಶ ಶ ಇದಿಲ್ಲ, ಯರ ವ ಶ ವ ಯರ ಲ ಯರ ರ ಯ, ಕರೆಕ್ಟಾ? ಯರ ಲ ವ ಶ ಶ ಸ ಹ ಳ ಕ್ಷ ಜ್ಞ. ನಿಮಗೆ ಉಲ್ಟಾ ಬರೆಯಕ್ ಬರ್ತೈತಿ ನೋಡ್ರಿ, ನನ್ನ ಹೆಸರು ಹೆಂಗ್ ಬರೀತೀನಿ. ರ ಜ ಶೇ ಖ ರ. ಇದನ್ನ ನೀವು ಕನ್ನಡಿ ಒಳಗೆ ಹಿಡಿದ್ರೆ ಸೀದಾ ಕಾಣ್ತೈತಿ. ದಿಸ್ ಇಸ್ ಮಿರರ್ ರೈಟಿಂಗ್ ಅಂತಾರೆ. ಓಕೆ, ನಾವು ಸಿ ಮ ಲ ಗಿ ಹಾ ಳ. ದಿಸ್ ಇಸ್ ಮಿರರ್ ರೈಟಿಂಗ್. ತಿಳಿತಾ? ಈ ಇರ್ಷಾದ, ಇರ್ಷಾದ್ ನೋಡಿ, ಹೌದಲ್ಲ? ಯು ಕ್ಯಾನ್ ಹೋಲ್ಡ್ ಇಟ್ ಇನ್ ಫ್ರಂಟ್ ಆಫ್ ಮಿರರ್, ಯು ವಿಲ್ ಗೆಟ್ ಅ. ಆಯ್ತಾ? ಇದು ನಾವು ಬಿ ಎ ಒಳಗಿದ್ದಾಗ ಒಬ್ಬರಿಗೆ ಒಂದು ಲೆಟರ್ ಬರ್ದಿದ್ವಿ. ನೀವು ಬರೀರಿ, ಯಾರಿಗಾರ ಬರೆಯಂಗಿದ್ರೆ ಬರೀರಿ. ಹೆಂಗ, ಈ ಲೆಟರ್ ಏನು ಮಾಡೋಕೆ ಗೊತ್ತಾ? ಈ ಲೆಟರ್ನ ಇಲ್ಲಿ ಹರಿಬೇಕಿಲ್ಲಿ. ಎಷ್ಟು ಚಂದ ಕ್ರಿಯೇಟಿವಿಟಿ ಯೂಸ್ ಮಾಡೋಕೆ ಗೊತ್ತಾ? ಈ ಲೆಟರ್ ಇಲ್ಲಿ ಹರಿಬೇಕು, ಕಟ್ ಮಾಡ್ಬೇಕು, ಇದಿಷ್ಟು ಕಟ್ ಮಾಡಿ ಇಲ್ಲಿ ಲೆಟರ್ ಬರಿಬೇಕು, ಉಲ್ಟಾ ಬರಿಬೇಕು. ಈಗ ಹೇಳಿನಲ್ಲ ಹಂಗ ಚಂದ ಉಲ್ಟಾ ಬರಿಬೇಕು. ಈಗ ಉಲ್ಟಾ ಬರ್ದಿದ್ದ ಲೆಟರ್ ಏನೈತಲ್ಲ, ಇದು ಓದಕ್ಕೆ ಬರಂಗಿಲ್ಲ. ಇದು ಇದು ಓದಕ್ಕೆ ಬರ್ತಾನ? ಓದಕ್ಕೆ ಬರಲ್ಲ. ನೀವು ಓದ್ಬೇಕಾದ್ರೆ ಏನು ಮಾಡಬೇಕು? ಕನ್ನಡಿ ಮುಂದೆ ಇಡಬೇಕು. ಕನ್ನಡಿ ಮುಂದೆ ಹಿಡಿದಾಗ ಅವ್ರ ಮುಖನೂ ಕಾಣ್ಬೇಕು ಇಲ್ಲಿ, ಪ್ಲಸ್ ಓದಿರ್ಬೇಕು. ತಿಳಿದ? ಚಂದ ಐತಲ್ಲ? ಇಂಪ್ರೆಸ್ ಮಾಡಕ್ಕೆ ಯಾರಿಗಾರ ಹಿಂಗ ಲೆಟರ್ ಬರೆದು ಕಳಿಸ್ಬೇಕಪ್ಪ. ಓಕೆನಾ? ನೆಕ್ಸ್ಟ್ shear stress. Next chapter, shear stress. Okay. Now we'll come to the page. Look at here. This is a beam. The beam is subjected to transverse loads. The beam will have bending moment, or this one. Then the beam will have shear force diagram. Means the beam is resisting both stresses. The beam is resisting bending stress also, that we already studied. The beam is resisting shear stress also. Therefore we want shear stress, we have to study shear stress chapter. Understood? The beam will resist both shear stress resist ಮಾಡುತ್ತೆ, bending stress resist ಮಾಡುತ್ತೆ. ಹಾಗಾಗಿ ಇದನ್ನು ಸ್ಟಡಿ ಮಾಡಬೇಕು. ಇದು ಜಲ್ದಿ ಹೇಳಿಬಿಡ್ತೀನಿ, ಸಣ್ಣದಾದ ಚಾಪ್ಟರ್ ಇದು. ಓಕೆ, ಈ equation you have to remember. See here, this is your rectangle, this is a neutral axis. Shear stress is equal to F A y dash divided by I B. ಓಲ್ಡ್ ಚಾಪ್ಟರ್ ಒಳಗಡೆ, ಪ್ರೀವಿಯಸ್ ಚಾಪ್ಟರ್ ಒಳಗಡೆ ಹೆಂಗ ದೊಡ್ಡ ಇಕ್ವೇಶನ್ ಇತ್ತಲ್ಲ, ಹಂಗ ಇಲ್ಲಿ ಈ ಇಕ್ವೇಶನ್ ಅದು ಎಫ್ ಎ ವೈ ಬಾರ್ ಬೈ ಐ ಬಿ. ವಾಟ್ ಇಸ್ ಎಫ್? ಎಫ್ ಅಂದ್ರೆ ಶಿಯರ್ ಫೋರ್ಸ್. ವಾಟ್ ಇಸ್ ಎ? ವೆರಿ ಇಂಟ್ರೆಸ್ಟಿಂಗ್. ಎ ಅಂದ್ರೆ ಏನು? ಎ ಮೀನ್ಸ್ you have to mark one interested fiber. Let us consider this is your interested fiber, II, interested, and A means area above the interested fiber. That is area above interested fiber. Area above interested fiber means this area. Okay. Now tell me, if I am interested here, then what happens? Area above that one is no, that is not there, therefore 0. Then when you come below portion, then area below the line, if you are interested in this line, then this is your area. If you are interested here, either this area or this area, correct? That is your area above the interested fiber. Then what is y bar? Y bar, it is y dash. Once again I will draw the figure. Neutral axis, this is interested fiber, then this is your area, correct? Now this distance is called as y bar. What is y bar? Y bar is distance between neutral axis and CG of area, CG of the area, correct? That is your y bar. Then I is a moment of inertia, B is a width of interested fiber, correct? Now look at here, once again, tau equal to f a y dash by I b. Okay, tau is directly proportional to a and y bar. Tau is inversely proportional to b. Remember these two. Okay, I am not writing tau is directly proportional to f and tau is inversely proportional to I. This is wrong. Why? Because f and I are constant. Correct? Now we have two impressions here. we have two impressions here. One is tau is directly proportional to area and y bar. Then tau is directly proportional to 1 by b. Now look at here. This area and y bar, together it is called as static moment. Statical moment. That statical moment means area into y bar. Area into y bar. Correct? Means what? Now, once again, shear stress is directly proportional to statical moment. Statical moment. And shear stress is directly inversely proportional to B. ಅಂದ್ರೇನು B ಜಾಸ್ತಿ ಆದಂಗೆಲ್ಲ ಸ್ಟ್ರೆಸ್ ಕಡಿಮೆ ಆಗುತ್ತಾ ನೆನ್ಪಿಟ್ಕೊಡ್ರಿ. ದೆನ್ ಏರಿಯಾ ಜಾಸ್ತಿ ಆದಂಗೆಲ್ಲ ಸ್ಟ್ರೆಸ್ ಜಾಸ್ತಿ ಆಗುತ್ತಾ ನೆನ್ಪಿಟ್ಕೊಡ್ರಿ. ಇದು ಯಾಕೆ ನೆನ್ಪಿಡ್ಬೇಕಂತ ಹೇಳ್ತೀನಿ. Now look at here. If I am interested here, what is area above the if I am interested if I am interested here, then what is the area above 0 andra shear stress 0. ನಾ ಕೆಳಗಡೆ ಬಂದ್ರ ಇದು ಏರಿಯಾ, ಇನ್ನು ಕೆಳಗೆ ಬಂದ್ರ ಇದು ಏರಿಯಾ, ಇನ್ನು ಕೆಳಗೆ ಬಂದ್ರ ಇದು ಏರಿಯಾ, ಇನ್ನು ಕೆಳಗೆ ಬಂದ್ರ ಇದು ಏರಿಯಾ. ಅಂದ್ರ ಏರಿಯಾ ಜಾಸ್ತಿ ಆದಂಗೆಲ್ಲ ಶಿಯರ್ ಸ್ಟ್ರೆಸ್ ಜಾಸ್ತಿ ಆದ ಜಾಸ್ತಿ 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 ಮ್ಯಾಕ್ಸಿಮಮ್. ಹಂಗ ಉಲ್ಟಾ ಜಾಸ್ತಿ 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 ಮ್ಯಾಕ್ಸಿಮಮ್. ಕರೆಕ್ಟಾ? ರೈಟ್. ಬಟ್ ಇಲ್ಲಿ ಬಿ ಟಾಪ್ ಒಳಗೂ ಬಿ ಇತ್ತು, ಬಾಟಮ್ ಒಳಗೂ ಬಿ ಇತ್ತು. ಹಾಗಾಗಿ ಈ ಸೆಕೆಂಡ್ ಇಕ್ವೇಶನ್ ಅನ್ನು ಕನ್ಸಿಡರ್ ಮಾಡಲಿಲ್ಲ. ಟಾಪ್ ಇಕ್ವೇಶನ್ ಕನ್ಸಿಡರ್ ಮಾಡಿ ಡಯಾಗ್ರಾಮ್ ಹಾಕಿಬಿಟ್ಟೆ. ಡೌಟ್ ಇಲ್ಲ? ನಾವು ಲುಕ್ ಎಟ್ ಹಿಯರ್. ಇನ್ನೊಂದು ಡಯಾಗ್ರಾಮ್ ತೋರಿಸ್ತೀನಿ. ಓಕೆ, ಈ ಡಯಾಗ್ರಾಮ್ ಅದ್ದು ಸಿ ಜಿ ಇಲ್ಲದ. ಒಂದು ನಿಮಿಷ, ಒಂದು ಫೋನ್ ಬರಕತ್ತೈತಿ, ಮಾತಾಡಿ ಕನೆಕ್ಟ್ ಮಾಡ್ತೀನಿ. ಓಕೆ, we were okay, done. Where we were now in this case, however, top and bottom 0, top and bottom 0. See this interested, and if you come down, area increased, come down, area increased, come down, area increase means increase 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 increase, right? Till here increase. Then if you are here, then area is this much. Then if you are here, then area is same. Correct ಅಲ್ಲ? ಇದಕ್ಕೇನಂತಾರೆ? ಇದಕ್ಕೆ ವೆಬ್ ಅಂತಾರೆ. ಸಾರಿ, ಇದಕ್ಕೇನಂತಾರೆ? ಇದಕ್ಕೆ ಫ್ಲಾಂಜಾ? ವೆಬ್, ವೆಬ್. This is called as web, this is called as flange. Top of the web, this is top of the web, this is bottom of the flange. Both are somewhat very near to each other. Top of the web area ಇಷ್ಟೈತಿ, ಬಾಟಮ್ ಆಫ್ ದ ವೆಬ್ ಅಬೋವ್ ಏರಿಯಾನು ಅಷ್ಟೇ ಐತಿ. ಅಂದ್ರೆ ಏರಿಯಾ ಚೇಂಜ್ ಆಗಿಲ್ಲ. ಬಟ್ ಬಿ ಸಡನ್ ಡಿಕ್ರೀಸ್ ಆಗೈತಿ. ಬಿ ಸಡನ್ ಡಿಕ್ರೀಸ್ ಆಯ್ತಂದ್ರೆ ಏನಾಗುತ್ತ? ಬಿ ಸಡನ್ ಡಿಕ್ರೀಸ್ ಆದ್ರ ಟೋ ಸಡನ್ ಇನ್ಕ್ರೀಸ್ ಆಗುತ್ತೆ. ದೇರ್ ಫೋರ್ ನಿಮ್ದು ಡಯಾಗ್ರಾಮ್ ಹಿಂಗ್ ಹೋಗ್ಬಿಡುತ್ತೆ. ಹಿಂಗ್ ಗೊತ್ತಾ? ನೆಕ್ಸ್ಟ್ ಕೆಳಗೆ ಬಂದ್ರ ಏರಿಯಾ ಇನ್ಕ್ರೀಸ್, ಏರಿಯಾ ಇನ್ಕ್ರೀಸ್, ಏರಿಯಾ ಇನ್ಕ್ರೀಸ್. ಅದಕ್ಕೆ ಶಿಯರ್ ಸ್ಟ್ರೆಸ್ ಇನ್ಕ್ರೀಸ್, ಶಿಯರ್ ಸ್ಟ್ರೆಸ್ ಇನ್ಕ್ರೀಸ್ ಇಲ್ಲಿ ತನಕ ಬರ್ತದೆ. ದೆನ್ ಇದಾದ್ಮೇಲೆ ಸ್ಲೋಲಿ ಡೌನ್. ಕರೆಕ್ಟಾ? ನಾರ್ಮಲ್ ಹುಡುಗರಿಗೆ ಹಿಂಗ್ ಬರದ್ರ ಏನು ಅರ್ಥ ಆಗಲ್ಲ. ಇದನ್ನ ದಿಲ್ ಅಂತಾರ ಅವರು, ಹೌದಾ? ಬಟ್ ನಮ್ಮ ಹುಡುಗರಿಗೆ, ಸಿಂಗಲ್ ಹುಡುಗರಿಗೆ ಹಿಂಗ್ ಬರದ್ರೆ ಏನಂತಂದ್ರ ಏನನ್ಬೇಕು? ಇದನ್ನ ಶಿಯರ್ ಸ್ಟ್ರೆಸ್ ಡಯಾಗ್ರಾಮ್ ಫಾರ್ ಟಿ ಸೆಕ್ಷನ್ ಅನ್ಬೇಕು. ಯಾರಾದ್ರೂ ಹಿಂಗ್ ತೋರಿಸಿದ್ರ, ಎರಡು ಕೈ ಹಿಡಿದು ಹಿಂಗ್ ತೋರಿಸಿದ್ರೆ ಏನು ಅಂತಂದ್ರ ಟಿ ಸೆಕ್ಷನ್ ಅದು ಶಿಯರ್ ಸ್ಟ್ರೆಸ್ ಅಂತ ಹೇಳ್ಬೇಕು. ರೈಟಾ? ನಾವು ಐ ಸೆಕ್ಷನ್ ಹಾಕಿ ನೋಡ್ರಿ. ನಾವು increase, B sudden decrease, stress sudden increase, then decrease, increase, then the same thing, right? This is your shear stress. Arthata? Next, we have some formulas. That formulas I will show here. ಈ ಫಾರ್ಮುಲಾ ನೆನಪಿಟ್ಟು ರೆಕ್ಟ್ಯಾಂಗ್ಯುಲರ್ ಸೆಕ್ಷನ್ ಟೋಮ್ಯಾಕ್ಸ್ ನಾಟ್ ಅಲ್ಲ ಟೋಮ್ಯಾಕ್ಸ್ ಸೆಂಟರ್ ಒಳಗಿರ್ತದ ವ್ಯಾಲ್ಯೂ ಎಷ್ಟಿರ್ತದ ಅಂತಂದ್ರೆ ಇಷ್ಟಿರ್ತದೆ ದಟ್ ಈಸ್ ಟೋಮ್ಯಾಕ್ಸ್ ಈಕ್ವಲ್ ಟು 1.5 ಟೈಮ್ಸ್ ಟೋಮೀನ್ ದೆನ್ ಸರ್ಕ್ಯುಲರ್ ಸೆಕ್ಷನ್ಗೂ ಕೂಡ ಎಲ್ಲಿರ್ತದ ಸೆಂಟರ್ ಒಳಗಿರ್ತದ ಟೋಮ್ಯಾಕ್ಸ್ ಎಷ್ಟಿರ್ತದ 4/3 ರೆಕ್ಟ್ಯಾಂಗಲ್ಗೆ 3/2 ಟೈಮ್ಸ್ ಟೋ ಆವರೇಜ್ ಸರ್ಕಲ್ಗೆ 4/3 ಟೈಮ್ಸ್ ಟೋ ಆವರೇಜ್ ನೋಡಿ ನೆನ್ಪಿಡಕ್ಕೆ ಈಸಿ ಅದ 3 2 4 3 ರೈಟ್ ಟ್ರಯಾಂಗಲ್ ಬಂದಾಗ 2 ಬರ್ತವೆ ಇಲ್ಲಿ ನೋಡು ಒಂದು ಇಲ್ಲಿ ಬರ್ತದ ಒಂದು ಸೆಂಟ್ರಿಗೆ ಒಂದು ಈಕ್ವಲ್ ಏರಿಯಾ ಆಕ್ಸಿಸ್ ಅಂತಾರೆ ಒಂದು ಸೆಂಟ್ರೋಡಲ್ ಆಕ್ಸಿಸ್ ಅಂತಾರೆ ದಿಸ್ ಇಸ್ ಈಕ್ವಲ್ ಅಲ್ಲ ಸೆಂಟರ್ ಆಕ್ಸಿಸ್ ಅಂತಾರ ಒಂದು ಸೆಂಟ್ರೋಡಲ್ ಆಕ್ಸಿಸ್ ಅಂತಾರೆ ಸೆಂಟರ್ ಆಕ್ಸಿಸ್ ಅಂತಂದ್ರ ನ್ಯೂಟ್ರಲ್ ಆಕ್ಸಿಸ್ ಅನ್ನೋಣ ಇದನ್ನ ಸೆಂಟ್ರೋಡಲ್ ಆಕ್ಸಿಸ್ಗೆ ನ್ಯೂಟ್ರಲ್ ಆಕ್ಸಿಸ್ ಅನ್ನೋಣ ಸೆಂಟರ್ ಆಕ್ಸಿಸ್ಗೆ ಬೇರೆ ಹೆಸರು ಕೊಡೋಣ h/2 ಆಕ್ಸಿಸ್ ಅನ್ನೋಣ h/2 therefore tau h/2 ಇದು ಸೆಂಟ್ರೋಡಲ್ ಆಕ್ಸಿಸ್ ನ್ಯೂಟ್ರಲ್ ಆಕ್ಸಿಸ್ ಇದು h/2 ಆಕ್ಸಿಸ್ okay tau h/2 3/2 tau average tau neutral axis 4/3 tau average ಈ 3/2 4/3 ಒಳಗೆ ಯಾವುದು ದೊಡ್ಡದು 3/2 ದೊಡ್ಡದು 4/3 ದೊಡ್ಡದು ಯಾರು ಹೇಳ್ತೀರಿ
4/3
4/3 ದೊಡ್ಡದಲ್ಲ 3/2 ದೊಡ್ಡದು 3/2 ಅಂದ್ರ 1.5
ಸರ್ 3/2
ಕರೆಕ್ಟ್ ಅಲ್ಲ
ಕನ್ಫ್ಯೂಸ್ ಆಯ್ತು
right okay now 3/2 is bigger means this is tomax ಭಾಳ ಇಂಪಾರ್ಟೆಂಟ್ ಫ್ರಮ್ ದಿಸ್ ಒಂದು ಕನ್ಕ್ಲೂಷನ್ ಬರುತ್ತೆ ಏನಂತಂದ್ರ ಟ್ರಯಾಂಗಲ್ ಸೆಕ್ಷನ್ ಒಳಗಡೆ ನ್ಯೂಟ್ರಲ್ ಆಕ್ಸಿಸ್ ಒಳಗೆ ಶಿಯರ್ ಸ್ಟ್ರೆಸ್ ಜಾಸ್ತಿ ಇರಂಗಿಲ್ಲ ಬೇರೆ ಕಡೆಗೆ ಇರ್ತೈತಿ ಬಟ್ ಅದೇ ಬೇರೆ ನೋಡ್ರಿ ಯೋಚನೆ ಮಾಡ್ರಿ ಇಲ್ಲಿವಾ ನ್ಯೂಟ್ರಲ್ ಆಕ್ಸಿಸ್ ಐತಿ ಅಲ್ಲೇ ಶಿಯರ್ ಸ್ಟ್ರೆಸ್ ಮ್ಯಾಕ್ಸಿಮಮ್ ಐತಿ ಟಿ ಸೆಕ್ಷನ್ ನ್ಯೂಟ್ರಲ್ ಆಕ್ಸಿಸ್ ಐತಿ ಅಲ್ಲೇ ಶಿಯರ್ ಸ್ಟ್ರೆಸ್ ಮ್ಯಾಕ್ಸಿಮಮ್ ಐತಿ ಐ ಸೆಕ್ಷನ್ ನ್ಯೂಟ್ರಲ್ ಆಕ್ಸಿಸ್ ಐತಿ ಅಲ್ಲೇ ಶಿಯರ್ ಸ್ಟ್ರೆಸ್ ಮ್ಯಾಕ್ಸಿಮಮ್ ಐತಿ ನೆಕ್ಸ್ಟ್ ಸರ್ಕ್ಯುಲರ್ ಸೆಕ್ಷನ್ ನ್ಯೂಟ್ರಲ್ ಆಕ್ಸಿಸ್ ಐತಿ ಅಲ್ಲೇ ಶಿಯರ್ ಸ್ಟ್ರೆಸ್ ಮ್ಯಾಕ್ಸಿಮಮ್ ಐತಿ ಬಟ್ ಟ್ರಯಾಂಗಲ್ ಬಂದಾಗ ಏನಾಗ್ತೈತಿ ಟ್ರಯಾಂಗಲ್ ಬಂದಾಗ ಟೋಮ್ಯಾಕ್ಸ್ ಬ್ಯಾರೆ ಕಡೆಗೆ ಇರ್ತೈತಿ ಬಟ್ ಟೋ ನ್ಯೂಟ್ರಲ್ ಆಕ್ಸಿಸ್ ಕಡಿಮೆ ಇರ್ತೈತಿ ಇದು ನೆನ್ಪಿಟ್ಕೊ ಇದು ಟಿ ಸೆಕ್ಷನ್ ಐ ಸೆಕ್ಷನ್ ಇವೆಲ್ಲ ನಾವು ಹೇಳಿದ್ವಲ್ಲ ಇಲ್ಲಿ ಅದ ನೋಡ್ರಿ ಇವನ್ನ ಸ್ವಲ್ಪ ಶೇಪ್ಸ್ ಅನ್ನ ಬೈ ಹಾರ್ಟ್ ಹಾಕ್ರಿ ಇಲ್ಲಿ ವ್ಯಾಲ್ಯೂಸ್ ಅದಾವ ಅವ್ ನೋಡಿ ಬೈ ಹಾರ್ಟ್ ಹಾಕ್ರಿ ರೆಕ್ಟ್ಯಾಂಗ್ಯುಲರ್ ಸೆಕ್ಷನ್ ಹೇಳಿದ ದಿಸ್ ಇಸ್ ನಾಟ್ ದೇರ್ ಫಾರ್ ಯುವರ್ ಸಿಲೆಬಸ್ ಇದಕ್ಕೆ ಶಿಯರ್ ಫ್ಲೋ ಅಂತಾರ ದಟ್ ಇಸ್ ನಾಟ್ ದೇರ್ ದೇರ್ ಫಾರ್ ಚಾಪ್ಟರ್ ಕಂಪ್ಲೀಟ್ಸ್ ಎನಿ ಡೌಟ್ okay now last 10 minutes ಅದ ಲಾಸ್ಟ್ 10 minutes ಅಲ್ಲಿ ಏನ್ ಮಾಡೋಣ ಕ್ವಶನ್ಸ್ ನೋಡೋಣ ರ್ಯಾಂಡಮ್ ಆಗಿ ನೋಡ್ಕೊಂಡು ತಗೋಣ ಜಲ್ದಿ ಓಕೆ 193 ಇಂದ ನಿಮಗೆ ಆಲ್ರೆಡಿ ಇದನ್ನು ಕಳಿಸಿದಿನಲ್ಲ ನಿಮಗೆ 193 ಕ್ವಶನ್ ಲಿಂದ ಸ್ಟಾರ್ಟ್ ಮಾಡ್ರಿ ಇಲ್ಲಿ ತನಕ ಹೇಳಿದ್ದು ಇಲ್ಲಿ ತನಕ ಬರ್ತದೆ ಇಲ್ಲಿ 242 ತನಕ ಬರ್ತದೆ 242 ತನಕ 193 ಇಂದ ಸ್ಟಾರ್ಟ್ ಮಾಡಿ 242 ತನಕ ನೀವು ಯಾವ್ದಾದ್ರು ಕ್ವಶನ್ ಅನ್ನು ಸಾಲ್ವ್ ಮಾಡ್ಬೋದು ಓಕೆನಾ ಒಂದು ಕ್ವಶನ್ ನೋಡ್ಕೊಂಡು ಜಂಪ್ ಮಾಡ್ಕೊಂಡು ತಗೋಣ ಜಲ್ದಿ ನಾವು bending moment at a section tends to bend or deflect the beam and internal stress resists its bending ಕರೆಕ್ಟ್ ಐತಿ ಅದು ಬೆಂಡ್ ಆಗುತ್ತಂತ ಇದು ಒಳಗಲ್ದು ರೆಸಿಸ್ಟ್ ಮಾಡ್ತದಂತ Resistance offered by the internal stress due to bending is called as bending stress. Definition ಬರೋದು ಕೇಳೋಣ. Assumption ಕೇಳ ನೋಡ್ರಿ important. Assumptions generally made in the theory of simple bending is that the beam material is perfectly homogeneous isotropic. ಹೌದು. The beam material is stressed within the elastic limit. ಹೌದಲ್ಲ? ಹೌದು. Plane section before bending remain after bending. ಹೌದು. Therefore D option. ರೈಟಾ? ಸ್ಕಿಪ್ ಮಾಡ್ತೀನಿ ಒಂದಿಷ್ಟು, ಕೆಳಗೆ ಬರ್ತೀನಿ. 201. When a beam is subjected to bending moment, the strain in a layer is dash distance from the neutral axis. Yes.
Sir,
Equal to ನೋಡೋಣ. Now
Yes,
you
sir.
write that equation, m by I equal to f by y equal to E by R. Okay. Now we'll consider this f equal to y by R into E. Correct? Now what is the strain? This is a strain. Therefore strain is equal to y by R. Then what is y? Y is the distance of from neutral axis is y. Then what is the strain? Strain is a strain. Therefore strain and y is directly proportional. ತಿಳಿತಾ? ಓಕೆನಾ? ನೆಕ್ಸ್ಟ್ ಬೆಂಡಿಂಗ್ ಮೂಮೆಂಟ್ ಇಕ್ವೇಶನ್ ಎಲ್ಲಿ ಕನ್ಫ್ಯೂಸ್ ಮಾಡಿ ನೋಡು, ಇದು ಬಿಡು. m by I f by y E by R, m by y ತಪ್ಪಾತ್ ನಾವು. ಅದು ನೆನ್ಪಿಟ್ಕೊಡ್ರಿ. ಮೇ ಐ ಫಾಲೋ ಯು ಎಲಿಜಬೆತ್ ರಾಣಿ, that you can remember. Next, jump, come here. Section modulus Z of a beam is given by I by y. Correct? Next, jump. ಇಲ್ಲೊಂದೇನೋ ಚಲೋ ಐತೆ. For a given stress, ratio of moment of resistance of a beam of a square cross section placed its side, two sides horizontal to moment of resistance with the diagonal horizontal. ಇದು ನೆನ್ಪಿಡ್ಬೇಕು ನೀವು. ರೇಷಿಯೋ ಅಂತ, ರೇಷಿಯೋ ಮೊಮೆಂಟ್ ಆಫ್ ರೆಸಿಸ್ಟೆನ್ಸ್ ಅಂದ್ರೆ Z. See here, always remember moment of resistance under Z of a square beam, square cross section when placed two sides horizontal. ಹಿಂಗ Z of ಇದು to the moment of resistance to its diagonal horizontal. ಹಿಂಗಂದ್ರ Z ಇದು divided by Z ಇದು. ಓಕೆ, ಇದು ಆನ್ಸರ್ 1/√2 ನೆನ್ಪಿಟ್ಕೊಟ್ರಿ. ಜಂಪ್ ಇದು ನೋಡಿ. When a cantilever beam loaded at its free end, maximum compressive stress shall develop at
bottom fiber.
ಕಾಂಪ್ರೆಷನ್ ಕೇಳಾರ, ಕಾಂಪ್ರೆಷನ್ ಬಾಟಮ್ ಫೈಬರ್. ಕರೆಕ್ಟ್ ಆನ್ಸರ್. ಹಿಂಗಿರ್ತದ, ಇದು ಹಿಂಗಾಗ್ತದ. therefore bottom fiber will get a compression this compression. Correct? Next, ಇದು bending stress in a beam is dash bending moment, equal to bending moment, directly proportional to bending moment. Directly proportional to bending moment. ಇದು ಬಹಳ ಇಂಟ್ರೆಸ್ಟಿಂಗ್ ಇದೆ. A neutral axis of a beam, the layer are subjected to maximum bending stress, layer are subjected to minimum bending stress, layer are subjected to compression, layers do not undergo any strain. Correct. ರೈಟಾ? ಓಕೆ, ಮಾಡ್ರಿ. ಉಳಿದಕ್ಕನ್ನ ಸ್ವಲ್ಪ ಓದ್ರಿ, ಯಾವ ಡೌಟ್ಸ್ ಬಂದ್ರೆ ಕೇಳ್ರಿ. ಇಲ್ಲಿಂದ ಡಿಫ್ಲೆಕ್ಷನ್ ಸ್ಟಾರ್ಟ್ ಆಗ್ತದೆ. We'll just glance our timetable. Now, in the third day, we completed this CG, MI, bending stress, shear stress, and these three are completed. Tomorrow, this eccentric load is also completed. Eccentric load is also completed. Now we have to work on moment area method. Moment area method andre tomorrow slope deflection of a simply supported beam and cantilever ಇಲ್ಲಿ ತನಕ ನೋಡ್ತೀವಿ. ನಾಡ್ದ ಕಾಲಮ್ಸ್, ಅಚ್ಚ ನಾಡ್ದ ಟಾರ್ಷನ್ ಮುಗಿತು. ರೈಟಾ? ಈ ಸಂಡೇ ಟೆಸ್ಟ್ ಇರ್ತೈತಿ. ರೈಟಾ? ಆಸ್ ಪರ್ ಟೈಮ್ ಟೇಬಲ್ ಒಳಗೆ ಏನ್ ಹೇಳಿದಾರೆ ನೋಡ್ರಿ ಇಲ್ಲಿ, ಡೌಟ್ ಸಾಲ್ವಿಂಗ್ ಆ್ಯಂಡ್ ಪ್ರೀವಿಯಸ್ ಇಯರ್ ಕ್ವಶನ್ ಪೇಪರ್ ಅಂತದ. ಪ್ರೀವಿಯಸ್ ಇಯರ್ ಕ್ವಶನ್ ಪೇಪರ್ ನೀವು ಬೇಕಾದ್ರೆ ಸಾಲ್ವ್ ಮಾಡ್ರಿ, ಅಥವಾ ನಾನು ಒಂದು ಟೆಸ್ಟ್ ಇಡ್ತೀನಿ. ಓಕೆ, ಎಷ್ಟಂದ್ರೆ 5 ಮಾರ್ಕ್ಸ್ 5 ಮಾರ್ಕ್ಸ್ 5 ಮಾರ್ಕ್ಸ್ 5 ಮಾರ್ಕ್ಸ್ 5 ಮಾರ್ಕ್ಸ್ 5 6 30 ಮಾರ್ಕ್ಸ್ ಕ್ವಶನ್ ಪೇಪರ್ ತಯಾರು ಮಾಡ್ತೀನಿ. ಕ್ವಶನ್ ಪೇಪರ್ ತಯಾರು ಮಾಡಿ ಒಂದು ಟೆಸ್ಟ್ ಇಡ್ತೀನಿ. ರೈಟ್? ಓದ್ರಿ, ಜಾಸ್ತಿ ಓದ್ರಿ. 3 ತಿಂಗಳದೊಳಗಡೆ ಡೆಫಿನೆಟ್, 2 ತಿಂಗಳದೊಳಗೆ ಡೆಫಿನೆಟ್ಲಿ ಆಗ್ಬೇಕು. ಕಾನ್ಸಂಟ್ರೇಟ್ ಆನ್ 1 ಮಾರ್ಕ್ ಕ್ವಶನ್, ಕಾನ್ಸಂಟ್ರೇಟ್ ಆನ್ ಪೇಪರ್ 1 ಕ್ವಾಲಿಫೈ ಆಗ್ಬೇಕು. ಇದನ್ನ ಬಿಟ್ಟು ನಿಮ್ಗೆ ಇನ್ನೂ ಟೈಮ್ ಜಾಸ್ತಿ ಇದು ಇಲ್ಲ. ಯಾವುದು ಬರೀ ನಾವು ಥಿಯರಿ 2 ತಾಸು ಇಲ್ಲಿ ತಗೊಳ್ತೀವಿ, ಪ್ಲಸ್ ಕ್ವಶನ್ ಸಾಲ್ವ್ ಮಾಡ್ತೀರಿ. ಇದಾದ್ಮೇಲೆ ನೀವು ಇನ್ನೂ ಓದ್ಬೇಕು. ಯಾವ್ದು ಓದ್ಬೇಕು? ಜನರಲ್ ಸ್ಟಡೀಸ್ ಓದ್ಬೇಕು. ಒಂದ್ 2 ನಿಮಿಷ ಜನರಲ್ ಸ್ಟಡೀಸ್ ನೋಡೋಣ, ಸಿಲೆಬಸ್ ನೋಡಿಬಿಡೋಣ. ಫ್ರೀ ಇದ್ರಿ? ಓಕೆ, ಜನರಲ್ ಸ್ಟಡೀಸಿಗೆ ಸಿಲೆಬಸ್ ಫಾರ್ ಜನರಲ್ ಇಂಟೆಲಿಜೆನ್ಸ್ ಅವೇರ್ನೆಸ್ ಬರೋಣ. Questions will be aimed to testing the candidate's general awareness of environmental around him and her and its application in the society. Questions will also be designed to test the knowledge of ನೋಡಿಲಿ ಅರೌಂಡ್ ಹಿಮ್ ಅಂಡ್ ದ ಸೊಸೈಟಿ ಅಂತ ಐತಲ್ಲ, ಇದನ್ನ NCERT 6ನೇ ಕ್ಲಾಸಿಂದ 10th ಸೋಷಿಯಾಲಜಿ ಅಂತ ಬರ್ತೈತಿ. ಸೋಷಿಯಾಲಜಿ, ಸಮಾಜಶಾಸ್ತ್ರ, ಅದನ್ನ ಓದ್ಬಿಡ್ರಿ. ಅದ್ರೊಳಗೆ ಭಾಳ ಕಂಟೆಂಟ್ ಇರ್ತದ. ಒಂದು ಅಕ್ಷರ ಬಿಡ್ಲಾರ್ದಂಗೆ ಓದ್ರಿ. Okay, then questions will also be designed to test the knowledge of current events and of such matters of everyday observation and experience in their scientific aspects as may be expected of educated person ಅಂದ್ರೆ ಇದ್ರೊಳಗಡೆ ಕ್ಯಾಟಗರೀಸ್ ಮಾಡ್ರಿ. ಏನ್ ಹೇಳ್ಯಾರ ಅವರು? ಕರೆಂಟ್ ಅಫೇರ್ಸ್ ಅಂತ. ಕರೆಂಟ್ ಅಫೇರ್ಸ್ ಯಾವುದು? ಕರೆಂಟ್ ಅಫೇರ್ಸ್, ಕರೆಂಟ್ ಇವೆಂಟ್ಸ್ ಭಾಳ ಇಂಪಾರ್ಟೆಂಟ್. ಕರೆಂಟ್ ಇವೆಂಟ್ಸ್ ಮತ್ತೆ ಎವ್ರಿಡೇ ಸೈನ್ಸ್ ಅಂತಾರೆ ಇದಕ್ಕೆ. ಎವ್ರಿಡೇ ಅಬ್ಸರ್ವೇಷನ್ಸ್, ಎಕ್ಸ್ಪೀರಿಯನ್ಸ್ ಇನ್ ದೇರ್ ಸೈಂಟಿಫಿಕ್ ಆಸ್ಪೆಕ್ಟ್ಸ್ ಅಂತ ಹೇಳ್ಯಾರ. ಆಸ್ ದೇ ಮೇ ಎಕ್ಸ್ಪೆಕ್ಟೆಡ್ ಟು ಎನಿ ಎಜುಕೇಟೆಡ್. ಈಗ ಇವೆಂಟ್ಸ್ ಅಂದಾಗ ಏನಾಗ್ತಾವ? ಗೌರ್ಮೆಂಟ್ ಇವೆಂಟ್ಸು, ಸೈನ್ಸ್ ಇವೆಂಟ್ಸು. ಒಂದು ಕ್ವಶನ್ ಫಿಕ್ಸ್ ಹೇಳ್ತೀನಿ ನೋಡ್ರಿ. ಚಂದ್ರಯಾನ ಸ್ವಲ್ಪ ಚಂದ ಸ್ಟಡಿ ಮಾಡ್ರಿ, ಒಂದು ಕ್ವಶನ್ ಫಿಕ್ಸ್ ಅದ. ಓಕೆ, ಹಿಂಗ ಟಾರ್ಗೆಟ್ ಮಾಡ್ಬೇಕು. ಈ ರೀಸೆಂಟ್ಲಿ 6 ಅಥವಾ 7 ಮಂತ್ಸ್ 6 ಮಂತ್ಸ್ ಹಿಂದ್ಗಡೆ ಜನವರಿಯಿಂದ ತಗೊಂಡ್ಬಿಡ್ರಿ. ಜನವರಿಯಿಂದ ಇಲ್ಲಿವರೆಗೂ ಏನೇನು ರೀಸೆಂಟ್ ಆಗ್ಯಾವ ನೋಡಿ ಇವೆಂಟ್ಸ್, ಆ ಎಲ್ಲ ಇವೆಂಟ್ಸ್ ನೆನ್ಪಿಟ್ಬಿಡ್ರಿ. ಎವ್ರಿಡೇ ಅಬ್ಸರ್ವೇಷನ್ ಅಂತದ. ಎವ್ರಿಡೇ ಅಬ್ಸರ್ವೇಷನ್ ಅಂದ್ರೆ ಅವು ಬರ್ತಾವ. ಪ್ಲಸ್ ಪೊಲಿಟಿಕಲ್, ಕರ್ನಾಟಕದೊಳಗದಿರಿ, ಕರ್ನಾಟಕದ್ದು ಒಂದು ಸ್ವಲ್ಪ ಏನಾರ ಕೇಳ್ತಾರೆ. ಎಲೆಕ್ಷನ್ಸ್ ಆಗ್ಯಾವ, ಭಾಳ ಕಡೆಗೆ ಆಗ್ಯಾವ ಎಲೆಕ್ಷನ್ಸ್, ಹೌದಾ? ಅದ್ರ ಬಗ್ಗೆ ಒಂದು ಸ್ವಲ್ಪ ಕೇಳ್ತಾರೆ. ಕರ್ನಾಟಕದ ಅಂತಲ್ಲ, ಸೆಂಟ್ರಲ್ ಎಲೆಕ್ಷನ್ ಬಗ್ಗೆ ಒಂದು ಸ್ವಲ್ಪ ಕೇಳ್ತಾರೆ. ಓಕೆ, ಎಲ್ಲ ಕಡೆಗೆ ಆಗ್ತಿದಾವ. ನೆಕ್ಸ್ಟ್ ಎವ್ರಿಡೇ ಅಬ್ಸರ್ವೇಷನ್ ಅಂತ. ಎವ್ರಿಡೇ ಅಬ್ಸರ್ವೇಷನ್ ಅಂದ್ರೆ ಏನು? ಫುಡ್, ಕ್ರಾಪು, ಕೆಮಿಸ್ಟ್ರಿ, ಸ್ವಲ್ಪ ಫಿಸಿಕ್ಸ್, ಹೌದಾ? ಇವನ್ನೆಲ್ಲ ಸ್ವಲ್ಪ ನೋಡ್ಕೊಂತ ಹೋಗ್ಬೇಕು. ನೆಕ್ಸ್ಟ್ ದ ಟೆಸ್ಟ್ ವಿಲ್ ಆಲ್ಸೋ ಇನ್ಕ್ಲೂಡ್ ದ ಕ್ವಶನ್ಸ್ ರಿಲೇಟೆಡ್ ಟು ಇಂಡಿಯಾ ಅಂದ್ರೆ ಜಿಯೋಗ್ರಫಿ ಅಂಡ್ ಇಟ್ಸ್ ನೈಬರಿಂಗ್ ಕಂಟ್ರೀಸ್, ಎಸ್ಪೆಷಲಿ ಪರ್ಟೈನಿಂಗ್ ಟು ಹಿಸ್ಟ್ರಿ, ಕಲ್ಚರ್ ಅಂಡ್ ಜಿಯೋಗ್ರಫಿ, ಎಕನಾಮಿಕ್ಸ್ ಅಂಡ್ ಸೈನ್ಸ್, ಜನರಲ್ ಪಾಲಿಟಿ and scientific research. ಓಕೆ, ಇಲ್ಲಿಂದ ಹಿಡಿದು ಇಲ್ಲಿ ತನಕ NCERT 6th to 10th ಮುಗಿಯಿತು. 6ನೇ ಕ್ಲಾಸಿಂದ 10ನೇ ಕ್ಲಾಸ್ ತನಕ ಇಷ್ಟು ಓದ್ಬಿಟ್ರೆ ನಿಮ್ಗೆ ಫುಲ್ ಕವರ್ ಆಗ್ತದೆ. These questions will be such that they do not acquire a special study of any discipline. ಭಾಳ ಚೆನ್ನಾಗಿ ಹೇಳ್ಯಾರ. ಜಿಯೋಗ್ರಫಿ ಒಳಗಡೆ ಪಂಡಿತರಾಗ ಅವಶ್ಯಕತೆ ಇಲ್ಲ, ಹಿಸ್ಟ್ರಿ ಒಳಗೆ ಪಂಡಿತರಾಗ ಅವಶ್ಯಕತೆ ಇಲ್ಲ. ಅವ್ರೇನ್ ಹೇಳ್ಯಾರ, ಸ್ವಲ್ಪ ಸ್ವಲ್ಪ ನಾಲೆಜ್ ಇರ್ಬೇಕಂತ. ಸ್ವಲ್ಪ ಸ್ವಲ್ಪ ನಾಲೆಜ್ ಎಲ್ಲಿ ಸಿಗ್ತದೆ ನಿಮ್ಗೆ? 6ನೇ ಕ್ಲಾಸಿಂದ 10ನೇ ಕ್ಲಾಸ್ NCERT ಬುಕ್ಸ್. ಓಕೆ, ಡೌನ್ಲೋಡ್ ಮಾಡ್ಕೊಡ್ರಿ, ಫ್ರೀ ಆಗಿ ಸಿಗ್ತದ. ಡೌನ್ಲೋಡ್ ಮಾಡ್ಕೊಡ್ರಿ, ಭಾಳ ಚೆನ್ನಾಗಿರ್ತದ. ದಿನ ಒಂದೊಂದು ಚಾಪ್ಟರ್ ಓದಿದ್ರು ಕೂಡ ನೀವು ಆರಾಮಾಗಿ ಮುಗಿಸ್ಬೋದು. ರೈಟಾ? ಇದು ಅಪ್ಟಿಟ್ಯೂಡ್. ಓಕೆ, ಅದಕ್ಕೆ ಜನರಲ್ ಸ್ಟಡೀಸಿಗೆ ನೀವು ಹೊರಗಡೆ ಎಲ್ಲಿ ಹೋಗ್ಬೇಡ್ರಿ. ಬಿಕಾಸ್ ಇಯರ್ 10th ಲೆವೆಲ್ ಅಷ್ಟೇ ಕೇಳ್ತಾರೆ ಇವ್ರು. PUC ಇನ್ನೂ ಮುಟ್ಟಿರಂಗಿಲ್ಲ, ಅಂದ್ರೆ PUC ಇಲ್ಲ, ಡಿಪ್ಲೊಮಾ ಲೆವೆಲ್ ಅಂದಾರ ಅವರು. ಅಂದಮೇಲೆ 10th ತನಕ 6 to 10th ಅಷ್ಟೇ ಚೆನ್ನಾಗಿ ಓದ್ರಿ. ಈ ಓದಿ ಟೈಮ್ ಉಳಿತಂದ್ರೆ 11th and 12th NCERT ಓಪನ್ ಮಾಡ್ತಾರೆ. ರೈಟಾ? ಟಾರ್ಗೆಟ್ ನಿನ್ನೆ ಆಲ್ರೆಡಿ ಹೇಳಿದಿ ನಾವು, 30% ಆಫ್ ದ ಮಾರ್ಕ್ಸ್. 200ಗೆ 600 ಮಾರ್ಕ್ಸ್ ಬೇಕು ನಮಗೆ. ರೈಟಾ? ಮಾಡ್ರಿ. If you have any doubts, you can ask, or otherwise we'll end the meeting.
No doubt, sir.
Okay. Thank you. Good night.